One more definition I given. A set of data structures, related classes, and interfaces is collections framework. Collections framework definitions here seen. What is collection? An object that represents group of objects. What is data structures? Arranging data in different formats. That is collection framework advantages, reduces programming effort. Next, increases programming speed and quality. Next, allows interoperability among unrelated APIs. Collection classes and interface in which package? Util package. How many categories divided? 2 categories. What are those? Collection framework collection, legacy collection. Collection framework collection means JDK 1.2 and above versions. Class and interfaces collection framework collection. Legacy collection means 1.0 and 1.1. These 2 versions, legacy collections. Collection framework collection, how many subcategories divided? 3 categories. What are those? Core collection interfaces, general purpose implementations, more utility collections. Okay. Core collection interfaces, just foundation of collection framework. How many list of core collections are there? 10. What are those? Collection, list, set, map, sorted set, sorted map, navigable set, navigable map, queue, deck. Okay. 10 collections. Now, collection is a root interface. List, it maintains sequences. Set maintains sets. List, will it allow duplicate? List, yes. Set, no. Map is 1-dimensional or 2-dimensional? 2-dimensional. What it contains? Key value pairs. Key value pairs. Will it allow duplicate keys? No. Duplicate value? Yes. Okay. Set, map, these all you studied. Next. How many collections completed? 4. 4 collections completed. Sorted set interface. Fifth one, sorted set interface. A sorted set is a set in which elements are sorted. A sorted set is a set in which elements are sorted. Sorted set extends set interface. See, sorted set interface. A sorted set is a set in which elements are sorted. Sorted set extends set interface. Sorted set extends set interface. Set, will it allow duplicates? Set, no. Sorted set also doesn't allow, but what's the difference is elements are sorted. ascending order, descending order, alphabetical order, like that sorted. That is only sorted set. Set, sorted set. Only elements are sorted. Okay. Next. Sorted map interface. Sorted map interface. A sorted map is a map in which key value pairs are sorted based on keys. A sorted map is a map in which key value pairs are sorted based on keys. A sorted map is a map in which key value pairs are sorted based on keys. See, for example, map is one-dimensional or two-dimensional? Two-dimensional. Okay. Key and value pairs. Suppose employee number. Here 5,000 employee number and salary. Suppose employee number 106. Suppose 7,600. Again, employee number 102. Suppose 9,000. Okay. Employee number 130. Suppose employee number 130. Suppose 4,500. Like this we have. Here, what I given say, it is map interface. It is map, but it is not a sorted map. It is not a sorted map. It is key, it is value. Okay. What I given here, you observe, a sorted map is a map in which key value pairs are sorted based on keys. Here, this is one pair. This is one pair. This is one pair. This is one pair. Okay. While sorting, what will happen? First, which one comes? 101. Next, 102. Next, 106. Next, 130. But while sorting, what will happen? First place 101 as it is okay. This is comes here. This is comes here. Okay. 101, 102, 106, 130. Then it is sorted. While sorting, what will happen? This is 5,000 only will be there. 102 shifted. Then 9,000 also shifted. Okay. This 7,600 shifted. But keys sorted, values sorted means many problems will occur. Okay. Suppose 101 salary 5,000. If keys are sorted, values are sorted, then what will happen? This 4,500 comes here. Then this person's salary for this person comes. That problem occurs. That is the reason while sorting, what will happen? Keys only considered. Keys only considered. Suppose Gmail usernames, Gmail passwords. Username, password. To maintain username, password. Set recorder, map record. Set recorder, map record. Map record. In the map, key and value pair. Key is username or password. Username. Value, password. Keys sorted, values sorted. Username sorted, password sorted. Then what will happen? Your username, other people password. Other people username, your password. At last, no one can open Gmail. That will be happen. That's what, while sorting, keys only considered. Values are not considered. The association value always with that particular key only. If key position changed while sorting, value position also changed. What do you mean? That is only sorted map. Next, sorted map extends map interface. Sorted map interface extends map interface. Interface, can I inherit in another interface? Yes. Which keyword we use? Extends. Interface can be inherit in a class. Which keyword? Implements. Class, can I inherit in a class? Which keyword? Extend. Class can be inherit in interface? No. No extend, no inheritance is not possible. Class cannot be inherited in interface. You already studied. Here, sorted map is interface. Map also interface. Okay. Sorted map inherits from map. Here also. Okay. Next. Seventh one. Navigable set interface. Navigable set interface. It extends sorted set interface and it is used to navigate. It extends sorted set interface and it is used to navigate elements of a set. It extends sorted set interface and it is used to navigate elements of a set. I'll explain, just write it. Navigable map interface. It extends sorted map interface and it is used to navigate key value pairs of a map interface. It extends sorted map interface and it is used to navigate key value pairs of a map. It extends sorted map interface and it is used to navigate key value pairs of a map. It extends sorted map interface and it is to navigate key value pairs of a map. Here, navigating nothing but iterating, traversing, different words will call. Suppose it is set. First of all, element is here. Okay. Here, like these elements are there. Like this, we have elements. First, cursor is here. Cursor is here. We'll print this one. We'll move the cursor here. Again, this one will print. We'll move the cursor. Again, this one will move the cursor. Again, this one will move the cursor. Like this. So, this is called navigating, or we can call it as traversing. We can call it as iterating. This is navigating. Navigation methods are there. in navigable set, navigable map. Okay. You can perform some operation and after that you can move to next element. Again, you can perform some operation, you can move to next element. That is called navigating. That type of methods are available in navigable set, navigable map. Okay. Next, ninth one, queue interface. Ninth one, queue interface. Ninth one, queue interface. It is called as first in, first out list. It is called as first in, first out list. It is called as first in, first out list. Say queue. It is called as first in, first out list. It allows insertion at rear end and deletion at front end. It is called as first in, first out list. It allows insertion at rear end and deletion at front end. I'll explain. 10th one also write it. Deck. Here one more point. It extends collection interface. Deck. It is called as double-ended queue. So it is actually short form. D means double. E means ended. QUE. Queue. It is called as double-ended queue. It allows both insertion and deletion at both the ends. It allows both insertion and deletion at both ends. Front end and rear end. It extends queue interface. It extends queue interface. It extends queue interface. I'll explain. Note down differences between queue and deck. Differences between queue and deck. One side queue. One more side deck. Differences between queue and deck. One side Q, one more side deck. First, it is a first in, first out list. In a short, we are calling FIFO. It is called as first in, first out list. It is a first in, first out list on deck side. It is not a first in, first out list. Differences between Q and deck. Differences between Q and deck. One side Q, one more side deck. It is a first in, first out list. It is a first in, first out list. It is not a first in, first out list. Okay, that is one. It is a Q data structure. It is a double-ended Q data structure. It is a Q data structure. It is a double-ended Q data structure. It is a Q data structure. It is a double-ended Q data structure. I'll explain with the diagram. It allows insertion at rear end only. It allows insertion at both the ends. It allows insertion at both the ends. It allows deletion at front end only. It allows deletion at both the ends. It allows insertion at rear end only. It allows insertion at both the ends. It allows deletion at both the ends. It allows deletion at front end only. Now, whatever I given differences, just you observe. I'll explain all. Is it over? See here. Yesterday 4 collections I explained. Yesterday 4 collection interfaces. Now remaining 6. Sorted set. Sorted set nothing but set only. Only elements are sorted. Sorted set nothing but it is equivalent to set only. Only difference elements are sorted. Either ascending order or descending order or alphabetical order. something sorted. The sorted set extends set interface. Super interface is set only. Sorted map interface, it is map only, but key value pairs are sorted based on keys. Key value pairs are sorted based on keys. Sorted map is a map only. Only key value pairs are sorted. That is different. Sorted map extends map interface. Okay, sorted map interface extends map interface. Navigable set, navigable set interface. It is used to navigate elements of a set. It is used to navigate elements of a set. Okay. Navigation purpose we use. Navigable map. It is just a one-dimensional navigation. Here, two-dimensional navigation. That's it. Now, queue. It is called as first in, first out list. It is called a double-ended queue. Here, insertion at rear end, deletion at front end. It extends collection interface. Here, it allows both insertion and deletion, both the ends, front end, rear end. It is extends queue interface. Here, these all I'll explain now with a diagram. You observe. Don't write. I'll give time for writing. Here, index 0, 1, 2, 3, 4. This is called front end. This is called rear end. Suppose here 0, 1, 2, 3, 4. It is front end and rear end. For second category, this knowledge is required. Okay. Now, listen. Here, front end, rear end. Here, front end, rear end. Now, all collections appears like a normal arrays type only, diagrams. But the functionality of every collection somewhat different. Internal code different. Okay. Now, all appears like arrays only. Now, it is front end, it is rear end. It is front end, it is rear end. It is queue. Queue, insertion at rear end. From this way only inserted. Deletion at front end. From this way only deleted. Here, delete. Here, insert. Okay. Now you observe. From this way inserted. From this way deleted. That is called queue. But here, inserting like this also possible. Inserting like this also possible. Both sides we can insert. Deleting like this also possible. Deleting like this also possible. Deleting. Like this. Now, suppose one element comes here. The element stored here. One more element comes. The element stored here. One more element comes. Stored here. One more element comes. Stored here. One more element comes. Stored here. Okay. Now, which element inserted here first? 35. Until deleting of this one, it is not possible to delete this. If without deleting this one, it is not possible to delete this. Without deleting this one, it is not possible to delete this. Okay. It is called Q. Here, element inserted here. So okay, like this or like this inserted. No, somewhere inserted here. Like this inserted. Like this inserted. Like this inserted. Like this inserted. Now, here 45 also can be deleted. 23 also can be deleted. But in between not possible. Again, after deleting this one, again if you want to insert here, possible. But after deleting this one, again if you want to insert here, not possible. So it is called Q, it is called tech. Double, it is called first in, first out list basis. Here, not like that. Inserting like this possible, like this possible. Suppose here 45 deleted. One more element you can insert. But here 35 deleted, not possible. From this way only inserting. Q format. So, which element inserted first? 35. Which is going to be deleted first? 35. That's what it is called first in, first out list. But it is not a first in, first out list. Now, 45 deleted. Now, it is not compulsory. This is also deleted. Okay. And also, after deleting, one more element can be inserted here. Possible. Okay. That's what it is not a first in, first out list. It is not a first in, first out list. It is in data structures, it is called queue. In data structures, it is called double-ended queue. Here, front end only, rear end only inserting possible. Front end only deleting possible. But here, front end, rear end, both side you can insert. Front end, rear end, both side can be deleted. Write this one. Is it over? Here, Which element inserted first? 35. Which element is going to be deleted first? That's what it is called first in, first out list. But here, even this element also can be deleted now. That's what it is not a first in, first out list. This concept is called queue. This concept is called deck. That is only full form double-ended queue. Okay, both sides. That's what double-ended queue. Here, if you want to insert rear end only, we can insert. Here, both side we can insert. Rear side, front side. Here, front end only we can delete. Here, both side we can delete. That's the difference. Clear? Here, insert, delete. Here, insert, delete, delete. Clear? Now, this is about queue and deck. Now, total 10 collections, interfaces you have seen. Now, note on the hierarchy of one-dimensional collection interfaces. The hierarchy of one-dimensional collection interfaces. It is collection here list, here set, here queue. Here sorted set. It is deck. Here navigable set. Note on. Next, the hierarchy of two-dimensional collection class interface. Here map, sorted map, navigable map. The hierarchy of two-dimensional collection interfaces. Map, sorted map, navigable map. So total 10 interfaces. 10 interfaces, 7 interfaces one-dimensional, 3 interfaces two-dimensional. Very easy to remember. Which are maps? You observe map, sorted map, navigable map. These three two-dimensional. Remaining all one-dimensional. That's it. Okay. Map related interfaces two-dimensional. Remaining all one-dimensional. That's it. Very simple. Map, sorted map, navigable map. The hierarchy of two-dimensional collection interfaces. One, two, three, four, five, six, seven. Here 1, 2, 3. Total 10. Okay. Is it completed? Now, using navigable set reference, can I call set methods? Yes or no? Yes. Using deck interface reference, can I call collection methods? Yes. Using queue reference, can I call list methods? Can I call? No. Super interface, you can call. There is no relation. Okay. And reverse also not possible. Sub interface not possible. That purpose hierarchy required. This is about one-dimensional collection, two-dimensional collections hierarchy. Already given Java.util package classes and interfaces. How many categories divided? Java.util package classes and interfaces. How many categories divided? Two categories. What is first one? Collections framework collection. Second one, legacy collections. Collections framework collections means JDK 1.2 and above versions. Collection class and interface are called collection framework collection. Legacy collection means 1.0 and 1.1. These two versions, collection class and interface are called legacy collection. Legacy nothing but old. According to this topic, 1.2 new. According to this topic. Okay. 1.2 onwards up to 20. What are the versions, class and interface are there? All collection framework collection. Okay. Now, collection framework collection, how many subcategories divided? 3. What are those? Core collection interfaces, general purpose implementations, more utility collections. Okay. Core collection interfaces, general purpose implementations, more utility collection. Core collection interfaces completed. That is theory part only. Okay. Programming comes under second part. Now, second category. General purpose implementations. General purpose implementations. General purpose implementations. Note down. The core collection interfaces, implementation classes. The core collection interfaces, implementation classes are called general purpose implementations. The core collection interfaces, implementation classes are called general purpose implementations. See, whatever you studied 10 interfaces, those interfaces implementation classes. So whatever you studied, 10 interfaces, those 10 interfaces implementation classes are called general purpose implementations. Okay. Now, list of general purpose implementation classes. List of general purpose implementations. List of general purpose implementations. First one. Array list. Second one, linked list. Third one, hash set. Fourth one, linked hash set. Fifth one, tree set. Sixth one, hash map. Linked hash map. Tree map. Priority queue. Array deck. List of general purpose implementation classes. List of general purpose implementation classes. List of general purpose implementation classes. Array list, linked list, hash set, linked hash set, tree set, hash map, linked hash map, tree map, priority queue, array deck. I'll ask some questions. Give me answer. I'll ask some questions. Give me answer. 10 interface you studied, no? With that knowledge, it is possible to give answer. It is possible to give answer. These are classes. Each word, first letter capital, no space between words. Write clearly. Okay. In these 10 classes, how many list interface implementation classes are there? In these 10 classes, how many list interface implementation classes are there? How many? 2. What are those? Array list, linked list. How many set interface implementation classes are there? 3. What are those? Hash set, linked hash set, tree set. How many map implementation classes are there? 3. What are those? Hash map, linked hash map, tree map. How many queue implementation classes? 1. What is it? Priority queue. How many deck implementation classes? 1. What is it? See, very simple, no? So, seeing that interface ends with interface, with that only can give answer. Okay? So, just now you have seen 10 collections hierarchy. List one type. So, 2 lists are there here. Set one more type. 3. Map one type. Queue one type. Deck one type. Total 5. But total 10 interfaces are there. Sorted set is a set only. Navigable set is a set only. Linked sorted map is a map only. And navigable map is a map only. Those are maps. Okay, those are maps. So maps you have seen. And a collection is just a root interface at the top of the hierarchy. Okay. That means total five different concepts. List one concept, set one concept, map one concept, queue one concept, deck one concept. Okay. These all. Now, some more questions. It is possible to give answer. It is possible. In this total, how many one-dimensional? How many one-dimensional? How many two-dimensional? How many one-dimensional? 7. How many two-dimensional? See, with that knowledge only possible. No? Map, two-dimensional. Remaining all one-dimensional. Okay. Now, still some more questions possible. What is the difference between hash set and hash map? Hash set is one-dimensional. Hash map is two-dimensional. Next, hash set contains elements. Hash map contains key value pairs. Hash set, will it allow duplicate? No. Hash map, will it allow duplicate keys? No. Values allowed. Okay. Hash set, index based collection. Hash map, key based collection. See. What's the difference between linked hash set and linked hash map? Same differences, no? What's the difference between tree set, tree map? Same differences. So these questions only interview questions, but people are getting confusion. Okay. See, difference between hash set, hash map. Same. Difference between linked hash set, linked hash map. Same. Difference between tree set, tree map. Same concept. Okay. Now array list, linked list. Two concepts you have to study. What's the difference you have to learn? These three you have to learn. What's the difference you have to learn? Okay. Again, these three you have to learn. What's the difference you have to learn? All are maps only, but difference is there. Like that. Okay. One concept, very depth, you will see now. Here programming also. Because these are classes. Methods are there. Now, first one, array list. First one, array list. It is an array representation of list implementation class. It is an array representation of list implementation class. It is an array representation of list implementation class. Say array list. What is array list? It is an array representation of list implementation class. In this class, list interface implemented, but representation method array representation. Here, four types of representations are there in data structures. Array representation, nothing but linear representation, and the linked representation, nothing but double linked list. Like a single linked list, double linked list, circular linked list concepts are there. And indirect addressing, simulating pointers, like four type of representation will be there. Two concepts not there in Java. Indirect addressing, nothing but pointers related. Simulating pointers, like a pointers. Those concepts not there in Java. But two representations are there. One is array representation, one more linked representation. This is array representation, this is linked representation. Now, here every point important only from here onwards. Now, I'll show you array representation, linked representation, diagrams also I'll show you. Okay. First point, it is an array representation of list implementation class. Next, it is an implementation of linear list data structure. It is an implementation of linear list data structure. It is an implementation of linear list data structure. It is an implementation of linear list data structure. It supports all the operations of linear list data structure. It supports all the operations of linear list data structure. It supports all the operations of linear list data structure. Say array list. It is an array representation of list implementation class. It is an array representation of list implementation class. Representation method, they used array, list interface implemented. That is, I have to explain with the diagrams. Okay. It is an implementation of linear list data structure. That is also I have to explain with the diagram only. It supports all the operations of linear list data structure. Whatever is supported by linear list data structure, that is supported by this class. Okay. Next. It does not allow duplicate elements because it implements list interface. It does not allow duplicate elements. It does not allow duplicate elements. It does not allow duplicate elements because it implements list interface. It does not allow duplicate elements because it implements list interface. Because of list interface, duplicates are not allowed. Because of list interface. Okay. Array list initial capacity is 10. I'll explain. Array list initial capacity is 10. And load factor is 100%. Array list initial capacity is 10 and load factor is 100%. See, what will be happen is 10 elements memory allocated. Like this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Like this allocated. See what I don't write, that is no need to write. Array list initial capacity is 10. What we'll do, we'll create object like this. Array list AL equal to new array list. If you write like this, automatically 10 elements memory allocated. 10 elements allocated. That is called initial capacity. But the size of array list can increase, can decrease dynamically as needed. Depends upon requirement. That is possible. Now, array list initial capacity is 10. 10 allocated, you will insert one element. One more element. One more element. One more element. One more element. Like this, inserted. Okay, one more element like this. Once if it is full, then only 10 elements again increased. That is called load factor. Once if it is full, 100% if it is full, then only memory allocated for next. That is called load factor. Okay. Initial capacity 10, load factor is 100%. First 10 elements allocated. If all elements are filled, then only next 10 elements allocated. That concept is called load factor. Load factor, that is 100%. Okay. Now, it allows null values also. It allows null values also. It allows null values also. Null also we can pass. Next, it supports both homogeneous elements and heterogeneous elements. It supports both homogeneous elements and heterogeneous elements. Homogeneous means same type of element. Heterogeneous, different type. It supports both homogeneous elements and heterogeneous elements. Same type of elements can be maintained. Different type of elements also can maintain. How it is possible, I'll show you in the program. Okay. See, these all points you have to remember. Next, the size of array list can increase and can decrease. Size of array list can increase and it can decrease dynamically as needed. The size of array list can increase and it can decrease dynamically as needed. The size of array list can increase and it can decrease dynamically as needed. So, array list size, it can increase, it can decrease dynamically as needed. If elements comes, increased. If element deleted, decreased. That is dynamically done. That already told how it will increase, how it will decrease. First, what will happen? 10 elements allocated. When 11th element comes, one more copy created. All copied, renamed. These all explained, no? That is. The size of array list can increase and it can decrease dynamically as needed. Okay. These all points remember. Now I'll show you. Now. Suppose I'll open command prompt. How to see the profile of array list? Array different, array list different. Array is also different. Java P, java.util.array list. Here, somewhat different appears from here onwards. You observe. Somewhat different concepts appears. You observe. Here, angular brackets. It is called diamond operator also. Okay. So that is new concept. Capital E. You observe capital E. Here you observe question mark extends capital E. Okay. Here you observe capital T array. Okay. Here you observe question mark. Here question mark extends capital E. Here you observe question mark super capital E. Previous library you didn't see like this. It is somewhat different, no? This is one concept, generics. Generics concept. I have to explain, not completed. Present, what I'll do, see, I'll remove this capital E concept. One constructor I'll give. Now, present, this is the one constructor. I'll remove this package. I'll write some methods. I'll give some methods. Just to add methods, I'll give. You observe. Here, capital E, today you cannot understand. That is tomorrow class I'll explain. Capital E place I'm writing object. Okay. Capital E place I'm writing object. Now it is simple, no? Without confusion. That capital E tomorrow I'll explain. That is compulsory you have to learn. Okay. That capital E concept only you have to learn. That is tomorrow class I'll explain. First you write this one. After class. It is used to add an element at the end. It is used to add an element at the specified position. Is it over? Present only two methods are given. These two methods. These two methods, method name, what is there? Add. Method name same. Parameter list different. This concept is called method overloading. Are these methods are accessible? Yes. Are these instance methods or class methods? Instance methods. Okay. Now here parameter object. Parameter object. Can I pass string? Parameter is object. Can I pass string? Yes or no? How it is valid? Now parameter is object. If I pass string class object or string class reference, it is valid. How? String extends object. So subclass object, subclass reference assigned to superclass. So if we pass actual parameter is object. Okay. Here string. Here actual parameter is object. If you pass string, it is valid. It is upcasting. Okay, valid. Suppose if I pass integer, int, is it valid? Primitive data type. Here also on concept. You already studied into to integer. What is this? What is auto boxing? Okay, auto boxing. Integer superclass is object. It is called upcasting. So auto boxing, upcasting. With the two features, it is valid. If you pass integer, primitive type, it is automatically converted to integer type. This integer assigned to object type. Auto boxing, upcasting. So if parameter is object, anything you can pass. All classes are subclasses of object class. Even primitive type if you pass also with auto boxing feature converted. That's what valid. Here programming little bit different here. But all methods predefined. All method defined. Just method calling only. That is, I'll show you tomorrow. Tomorrow I'll see Ganesh.